I'm Shishir. Shishir, I work at ThoughtWorks. Been working with the continuous delivery practice group for last 1.5 years, and this is the time when I got chance to use really cool command line apps and also build few of my own. And before that, I was working mostly in Ruby on Rails. Over to Nikhil.
Yeah. Hey guys, Nikhil, Mungel. I work at ThoughtWorks Pune as a Ruby application developer. I also do a little bit of systems along with Ruby. So we are here to talk about command line applications. So why are we here talking about command line applications? Why are we talking about command line tools, things when you open up the terminal or the shell or the command prompt and type little characters in it? When we are constantly developing new idioms of user expression, we have touchscreen iPads, we have touchscreen phones, we have really powerful browsers with powerful JavaScript rendering engines. It's really pretty cool, right? But why are we still dwelling on the fact that you can still type commands into the terminal to get things done? So if we were to take a step back, these powerful, rich applications that we build for our end users, what do they run on? We need servers for them. You need operating systems. You need your languages. You need frameworks. You need IDEs. You need a whole lot of database servers. You need other services like third-party services. You also need a lot of tools like configuration management tools. You need Git, maybe Chef, maybe even a framework like Rails, let's say. Right? These are the tools that make those rich applications on the top happen. So, do these tools have a rich user interface to them? Well, some of them do. Some of them have recently started having graphical user interfaces on top of them. But traditionally or classically, all these servers that we use and all the heavy lifting that happens behind the scenes is governed by command line applications. There are a lot of command line applications like Git, Knife, which is the command line application for Chef, or the MySQL client, or the PGCTL for PostgreSQL. Uh, these command line applications enable us to talk to these things on the top, enables us to configure them, enables us to install them, even like do a whole lot of connect to them, do a whole lot of other things. So that makes CLI applications really important. Uh, the fun part about this is that the CLI applications work on a vehicle called as, let's say, the shell, or the command line itself, right? We have different kinds of shells which accept user input, relay it back to the application, come back with the output, and give it back to you. Uh, PowerShell is for Windows, Bash, ZSH, KSH, CSS. There is a lot of shells available that make command line applications possible. So the users of these command line applications are primarily developers, QAs, other people who are doing other technical things, and so on and so forth. It's typically not end users who would be maybe using an iPad or a touch phone. So there is a certain degree of expertise out there that you can assume, or if you don't want to assume that, you have to basically take in consideration that these are tools that are written by developers for developers, by developers for QAs, and so on. So let's talk a little bit more about CLI applications. They're lightweight. They are not as heavy. Like normally CLI application will not amount to like a nice 7 GB juicy download. It's a much more small, lightweight application, small in file size, really fast. These are the observations that you might make when using a CLI application. They are scriptable. This is the single most, or probably one of the single most attributes of a CLI application. Scriptability. Any command line application that we have, it's by default scriptable. You just take a few commands, stick it into a file, you call it a script, or other programs can programmatically invoke this particular CLI application, and so on. So this attribute of CLI applications makes them really stand out from other graphical user interfaces, wherein you'll have to have more elaborate scripts of, okay, go click here, go click there, and so on. So scriptable. Other thing is that command line applications offer a largely consistent user interface. This is because you are talking only about STD and STD out and STD ARR. which is relayed to you by all operating systems in more or less in a similar fashion. Like if you are, let's say, using the Git program, or if you are using the Ruby Gems program, it's going to behave the same on a Mac OS X or on a RHEL box sitting in your server. It's not going to behave any different. If you compare that with something like Photoshop, which ships for both Windows and Mac, it's a little different, right? Or forget Photoshop, like any other window tool, the placement of the buttons, the idioms that the operating system is following differ. Not so much for command line applications. So what makes command line applications good is something that Shishir will tell us about.
So we saw what are command line apps. We also saw what are the characteristics of command line app. Let's see what makes a command line app good. Like what are the features you will see in a good command line app. So the first one is luxury of ignorance. What it means is that the consumer of the command line app is both novice as well as expert users, and the command line app should be designed in such a way that if you don't know how to use it, the command should guide you towards the next set of tasks that you can perform on it. Say, for example, Rails. So I'm in a Rails app and I type Rails over there. So what do I get? I get the usage of the Rails command and set of other tasks that I can perform next. I want to perform generate after that. I want to figure out what generate does. So I say Rails generate, and I can see the available list of tasks that you can follow, that you can run on the after generate. So this way, the user doesn't really have to know what the command line app does. It actually you can discover while they run the app. This is not something new. Like this pattern has been followed. It's been there for a lot of popular utilities like SSH, make, run. If you just type the command, you'll see the usage pattern over here. So this is one of the features that you want in a good command line app, so that the user can actually figure out what he can do with the command instead of reading through 500 lines of line page, which is not bad, but still it helps to have a task-oriented interface to your command line app. Then is list astonishment. What it means is that you play well with the other ecosystem of commands. Like if when I test Rails, if I see the task that you can perform next, then you want that behavior consistent, because that's what I'm going to do if I see a new command line app. But let's take an example of bundle. So typically when I first installed bundle, what I expected it and ran bundle, what I expected it to do is show me the usage. But instead, what it does is that it goes and installs gems on my system. The problem is it's not even a reversible operation. Like it goes and changes my gem set, where all I was expecting it to see a usage. So this is a they could have done bundle install and given a way of putting default over there, might have been more helpful. So third is reversibility. So what it means is that any command that I execute, I should have a command to actually reverse the operation. So for example, if I do git commit and create a commit object, then I should be able to reverse it using git reset head. So this gives user the peace of mind to try out new things and see what it does, and then if it's not what you want, then you can roll back. So that's pretty important feature. But it's not true that all commands can't be reversible. Like git push is not reversible, but in that case, at least it should give us it should give you a prompt to the user saying that what you're trying to do is actually going to change the state of the graph. Do you really want to do it? Fourth was config files. So let's look at this command for a second. It's a tool called Knife. It's used in provisioning, and you can upload cookbooks to a server, which will be applied to various systems when the chef client runs. So now if I have to pass all the required parameters on the command line, like cookbooks, path to the cookbooks like server URL, it makes the UX really cluttered. Rather, what you do is that you provide all the default configuration in a config file. And if you want to override, sure, you can go ahead and you override specifying the options. But it always fall back to the defaults when you don't provide the option. So it makes the interface really clean. Like now I only say nice cookbook upload Apache 2 and not cluttered with all the other information around. I'll let Nikhil talk about the rest of the UX.
So during the course of this presentation, we are going to draw allusions to some of the few command line applications that we commonly use. Bundle is one, Ruby Gems is one, Knife is one. Knife is the CLI tool for Chef, which is another configuration management tool. What else do we talk about? What are the Ruby applications, command line applications, like really solid ones do we talk about? I think it's just these.
Yeah, that's pretty much it.
And then we keep on falling back to Git, because Git itself is a really, really mature command line application. Although it is not written in Ruby, it's one of the most mature command line suite that we have used. So one of the characteristics that we have noticed amongst all these command line applications that we have been using is that they always fail very gracefully, just like any other end user application, web application, mobile application that you might write. If you are going to fail, you should fail gracefully instead of printing out a cryptic message. You should offer suggestions, refer to a man page, so on and so forth. Like, let's see what Git does when I just ask it to do a Git pull without specifying absolutely any configuration. If I ask it to do a Git pull, it's going to say that, hey, you didn't tell me what do I merge with. And it's going to give you two options out there. It's going to give you one option in which you can specify just for this one time, give it a repository and a branch name or a ref spec, and it'll merge it. If you want like a permafix to this problem, you can take these 3 lines and stick it into your configuration, let's say, and it will not ask you this anymore. It additionally also refers you to look at git config for details. So this is a really good pattern to follow in command line applications. Failed gracefully, offer suggestions how to proceed next instead of giving cryptic error messages. So what else do we have? We have no hidden states. This is a pretty interesting one. If your application's behavior changes depending on the state the application is, if your application has multiple states and its behavior changes according to those states, your application should never hide that state from the end user. It should always put that somewhere there on the user interface. Like an example that comes to mind is like the older versions of the VI editor did not tell the user if the user was in a command mode or in an insert mode. So you would do something, go away, and come back later on, and you would forget what mode you are in, and that would result in some mistakes being made. So you have the mode being displayed in modern versions of VI and VIM. So that's an important part to note, as to not have any hidden states, hide nothing from the user, broadcast everything. In something like Git, which does not offer you an interactive window like this, Git status is a really powerful method of finding out what state you are in currently. So moving on to the next point, confirmations should be scriptable. So ideally, your application should have really minimal confirmations, should not ask interactive confirmations from the user, no matter what, unless it is something really critical. What happens is that if your app is constantly asking for a confirmation about doing something really mundane, the user is going to be conditioned to just hit enter or press yes or whatever it is. Not a good thing, because when something actually surprising comes up, the user is just going to instinctively go ahead, and there's going to be an oops moment out there. If you're going to have confirmations, you should have them scriptable. So let's look at one example about the Ruby Gems binary. So if I want to uninstall a particular gem, I issue the uninstall command to the CLI app gem, and it asks me. It tells me that my dependency graph is going to be broken if I uninstall this gem, and do I want to continue? And it asks me a yes or a no. So just to digress a little bit, this little thing out here, right? If you have a single lettered command, you have the capital command to be default. So I should not have to press Y. If I just press enter, it will assume Y. This is followed across most of the GNU core-utils and like a lot of other standard applications that I've used. So I'm going to go ahead and press no, and I can invoke gem uninstall with a -I flag that is going to ignore all dependencies. So this is a very good pattern. Although, so my default invocation can be an interactive mode invocation. but there is a flag that should be able to pass the command line application that gets rid of that interaction. It makes for easy scriptability. It makes it easier for other programs to invoke this application and so on. Other common flags out instead of -i. Actually, -i is a pretty strange flag. Normally, you have something like a -y that will assume like a default yes, which is prevalent in yum and dpkg and apt-get. Another way of doing this entire or modeling this entire user flow out here is to have a fail on default kind of a method. Like something like if you look at the earlier example of Git, right? It'll fail by default, or even RM, it'll just fail by default. If you don't pass a -f flag, it'll fail by or actually it doesn't fail by default. But so you fail by default, and you give a user an option that okay, if you want to go ahead, you should invoke with the -f flag. So even that is scriptability in a way. That doesn't work if you have a lot of interactions. If you have a single point of interaction, then having a -post flag works just fine. So this is the last point on the user interactions part about CLI applications. That's to honor piping. Your CLI applications, so you're going to write CLI applications and they're going to be like really interactive and fun for your users to use. In the same way, they should also be equally easy for other applications to invoke, or they should, you should make your CLI app in such a way that the user can string it together in a chain of other CLI apps by using the standard piping that is given by the system and use it. So an example would be, so this is a standard development.log that is outputted by Rails. It's meant for the user to read and it's meant to be displayed on a TTY. But if you open it up in an editor and set its mode to not be able to parse a TTY output, this is what you'll see. This is the actual text, right? All these escape codes out here, these are color codes that make the output colored. Not so nice if you want to maybe pipe it to a utility that is not connected to a TTY. If you pipe it to grep, it is going to work because grep is going to, the std out of grep is going to connect to the TTY. But if you, let's say, redirect it to a file, then it's going to look like this. So use the TTY method that is prevalent on all your streams in Ruby. Make sure that if you are going to put colors in your output, you are doing it only if the command is being invoked from a TTY. So that's the bit about piping. And let's talk about why are we talking about Ruby.
So we saw the characteristics of command line app. We also saw a few of the features that makes command line app good. At least that's what we believe. Now the question is why Ruby? Why? Like it's a scripting language. It's a good scripting language. It provides a lot of methods for text manipulation. You can build really good abstractions in Ruby, and there are a lot of gems that can help you to actually write command line applications. Few of them we will discuss later on in the second half of the presentation. And last, like where we picked up was there's ample examples you can pick from. Like they're very nicely written command line apps like Knife, Gem, Rails to look at that source code and see how they do it. So that's good for a start. Whoever wants to write a command line app. And also we all love Ruby, so yeah, we write all the apps and we try to write all the apps in Ruby. So moving on, what's the structure of CLI app? It's pretty much the same with any other app. You take input, there is an execution of the module, and then you display output to the user. The difference is in command line app, your standard input output is the UI or the UX, which is good because it gives a very limited. There is a very small manipulation that you can do on the command line with only 3 strings. So you have to really think about how you will make it more usable for your users. So that's STDI is UI UX. Then output, yeah, that's pretty much governed by the app, the execution module that you have written. So app should generally respect the exec codes. That's one of them. 0 for success and rest all failure. And since execution being a standard Ruby library, there is we all know how to write it. So I'll let Nikhil talk about what are the different ways of parsing input.
Thanks. So talking about input, which is an important or maybe half the work of a CLI application if you don't use existing libraries. So you have the STDN coming in from the environment into your system. Out here you can access it using argv, the argument vector, and you can play around with it. You can try to parse things out of it. You can have a syntax for your application. You can do things so on and so forth. That's the raw way of doing it. To parse options, you have the option parser, which is something which is standard in Ruby. It's included in Ruby in the standard stdlib. So you can use an opt parse. We are going to look at an example of this shortly. And something more fun is all the libraries that already exist for writing CLI applications. You're probably talking about Thor, which is used heavily in Rails, or a lot of the Mixlib Suite. We are going to talk about this in a bit. So these libraries make a lot of heavy lifting on the input-output front really simple for you. They give you a lot of things for free out of the box, like printing out usage banners, formatting the textual output that your application is emitting. Most of these, if you don't use one of these, you'll be spending a lot of time just parsing your input, coming up with elaborate sprintf statements to correctly format output for an 80-character screen, etc. So this is an example of an option parser, how the option parser works in Ruby. You just invoke a new option parser object, you give it a banner, and for free you will get it out here. Like if I invoke, this is just a snippet of an indicative snippet of the code, is not the entire Ruby file. Most of our examples in this presentation are just small indicative snippets. You specify a banner and you'll automatically get it if --minus help is invoked on the application. Or you have the on method. So you can, so here I've just done a -v and a --minus verbose. So that will get printed out here. The verbose thing will get printed out here. And I can parse it and I can programmatically access these things inside my library. So using tools like this makes writing CLI apps a whole lot better than manipulating the raw argument vector that is coming in. Mixlib Suite. So we keep on talking about Chef and Knife because Knife is a really powerful CLI application that we have happened to use. So the good guys at Opscode have distilled out a few gems that they call the Mixlib Suite. Actually, just a collection of gems. I'm calling it a Mixlib Suite. They're scoped by the Mixlib. So this is an example of the Mixlib CLI. So this do we have anybody in the room who has used Knife or, right? So it's, you guys must have seen, right? It's a pretty solid command line interface. So you can have that same thing for free in your own CLI app if you extend from the Mixlib CLI module. So out here you specify a config file, let's say. So I can pass in a -c while invoking the CLI application. And so it's essentially the same thing. We're just calling it out just to put things out there that we know are good and solid to work. It'll give you a nice syntax. You can have things like required, not required. Just get rid of the entire bit about parsing input and output. So if you look back on the example that Shishir gave us about defaults, having defaults and configuration files, it's always a good idea to have your CLI application depend on the configuration file rather than all the arguments always being passed in from the command line invocation itself. So on that note, having a .rb configuration file is a pretty nice pattern that we have seen work. This is also afforded to us by the Mixlib Suite. You can have, so these are like basically methods, but you can, yeah, I mean, they just don't have colons. You can have parentheses out there. They don't have those colons and like an XML or YAMLish syntax, etc. It's well-formed Ruby. It's an RB file. You can also execute some arbitrary Ruby code on the top and generate these values, let's say. So it's really powerful to have a configuration file itself that is written in Ruby. And doing it is pretty simple. You just extend from the Mixlib CLI module and you just like put all the methods out here. So it'll enforce the fact that you have to give it defaults. And once you do that on your IRB, if I just do a myconfig.server URL, I'll get server.remote because I'm including config.rb, which specifies server.remote. If I did not specify this, it would fall back to server.local, which is the same default, let's say, in this particular example. So, so using the Mixlib Suite is something that we definitely recommend that you guys at least go and look into because it's really powerful. The way it handles input and output for you, it's everything just works out of the box pretty nicely. And let's move on to another framework called as Thor that Shishir will tell us about?
So Thor is similar. Like Thor does a lot of stuff other than CLI app, but it's heavily used in Rails and Vagrant and other good CLI apps to build upon. So Thor is a Rake style. It gives the Rake style command line usage. Like what you do is you declare a class test and have an So you have a class test and you have a public method example on it. The way it translates on the command line is test::example. Your description becomes the input of the task, and you can pass in method options by giving. You can set the options on the command line using the method options method. So why Thor? Like Mixlib CLI is good. All the other there are a lot of other libraries for this. The Thor A is convention based. It enforces object orientation in your command line apps, because whatever task or command line utility that you write, it is always in form of class and the public method on in it. You can also chain executions. Like if I want a sequence of commands to be invoked from another, Thor will resolve the dependencies and make the dependency graph and execute it correctly. So it's definitely one of the good libraries to look at when you are planning to write a CLI app. So moving on to testing. So we talked about the structure of CLI app. We talked about what makes CLI app good. We also talked about few of the libraries for input parsing. So now how do we test all of this that we have, the CLI app that we have written? So referring back to the structure that we saw a few slides back, was CLI app has an input, execution, output. So input, like we saw, it's mostly third-party libraries. There's a lot of boilerplate code in there, and there is no real value actually in testing the third-party frameworks. So yeah, we can leave input out of the testing part. Execution again is a standard Ruby classes and modules that you write, and there are very good testing frameworks already available for it, like TestUnit, RSpec, Cucumber, etc. The tricky bit though in execution is that your command line app will interact with the system. It will either change the state of the file system, spawn a new process, make network calls, or something similar. And if you have to test those execution, there are typically two ways of doing it. Either you mock the calls to the system, like using gems like mockfs or fakefs, where you can mock every calls that are made to file utils and write code around it. But the problem with mocking, the mocking is very tightly coupled with the implementation. So say for example, I'm writing a command line utility to do something with makediff, and I mock makediff command, the call file system call. Now if I plan to change it to makediff_p, which doesn't change the behavior, but my test will start failing. So that's not a good way of writing tests. And also there are very few libraries to stub out network and processes, though they are there, which comes with the same problems that mocking gives. So what do we do? So what we did was when we write CLI apps, we started running them in containers. So nowadays containers are very cheap. Like you can have VirtualBox plus Vagrant on top of it, and you can have a very cheap command line container available to you. Also, Linux comes with containers like LXC, OpenVZ, which you can play around with. So what we do is that we write the command line app, we let it and run it in a container, let it change the file system, the server processes, memory, whatever it needs. If it breaks, it breaks. We kill the container and we move on to we make a new container and start experimenting again. So going back to the mocking thing, even though we mock, we have to actually execute it on a system and see whether it works. Whereas in this scenario, you can always know that the command you are writing has, whether it has a specified behavior or not. So this is something you guys can try when writing CLI apps. Pass it on to Nikhil.
Yeah. So coming to the last segment of this presentation, we're going to talk about a few focused areas that you need to pay heed to when you're writing a solid command line interface application. So one such thing is streams and signals. So it's really important for you to play nicely with the streams, the STD input, output, and error streams that our application gets, that our application maybe invokes or puts up another sub process. Let's say, how are you going to play with that? Few things come to mind. One of the things is that, let's say, if your application is going to take input from a file, like if you're going to invoke the command line application with an argument as a file, you should also be ready to take the same contents of the same textual file if it is piped into the command line application. So you should be open to taking in an to read a file from the input stream or from the disk itself. So be prepared to do both these things. Error messages. If you are going to print error messages, you should print them out on the std err and not the std out. That just makes sense because that's what other applications will expect your application to do. You never know what your users want to do with your command line applications. They might want to just redirect the error stream to maybe another TTY, or just not ignore it, like how you typically do with the find command. You just ignore the std err. There could be many use cases. What about the streams that are associated with the sub-processes that your command line application is going to spawn? How are you going to talk about those? Like, the really simple, cheap way to do is like invoke a command in backticks or using kernel.system. It works, but it doesn't give you like very fine-grained control over the sub-processes themselves. We would recommend using something like popen3, which is again shipped as stdlib in Ruby. That will give you a handle on the input stream, the output stream, as well as the error stream. You can also use something called as, I have slides for this. You can also use something called as the Mixlib shellout. The Mixlib shellout gives control over these two streams. This is the portion that we are talking about, what popen3 and Mixlib shellout handle nicely for you. So what Mixlib shellout does, it doesn't use any of the abstractions that are given to you by Ruby. It writes its code right from io.select, which itself places a system call to select.h. So it's really built up right from the file descriptors bit to giving an object-oriented interface in your Ruby world. So as a result of it, it works really nicely with any Linux, GNU Linux-based system, BSD system, as well as any Windows system. It's really portable in that regard. It's nice to have. It's nice to use the Mixlib shellout library. Moving on, okay, and another bit about signals I mentioned on the slide is that you should respect if somebody is sending an application a 15 signal, like a kill minus 15 or something, a control C basically invoked on your. If your application is a particularly long running application, you should honor that and interrupt gracefully and just exit the application. You should not. There shouldn't be a situation where somebody has to invoke a kill minus 9 on your application. So these are interrupts that can be like trapped by the Ruby process, and you can work with it nicely. Moving on to plugin architectures, it's always good to have a plugin based architecture for any application, is what we believe in. Knife and Vagrant do a particularly good job of it by having drop-in plugins. If you just drop in a plugin and expose a particular interface that the mother CL app expects, it will directly integrate those subcommands into you. So even the applications that you should write, it's worth considering. Because you never know all the use cases that your end users might have for the CL applications. It's always nice to have these plugins where you can drop in and the CL app naturally just like picks it up into its ecosystem, absorbs it, and displays it to the end user. Moving on to hooks, Shishir will tell us how to effectively implement them.
So, plugin architecture, though it's good, it gives a lot of extensibility. It's not something you want to do if all you care about is on a success or a failure of a command you want to execute a simple script. So hooks come into that group. Like you can provide, your CLI app should provide hooks for important operations. Like Git comes to my mind. When you do git push, there are hooks before which you can drop in any arbitrary script that you want to execute. So hooks is something which gives a cheap way of doing something before any important event that occurs in your CLI app. And plugin architecture and hooks together makes your command line app really extensible. So then comes the logging. We all know the importance of logging in any app, and CLI app is no different. But CLI app, all the interfaces is through the options that we pass. So when you're considering logging, keep in mind about like a good practice would be to have -v flex support for info and debug, and -q for maybe fatal, so that user can change like how much noise he sees on the command line. And std out can be the default logging place, but you should also allow user to specify it should be configurable to a file. Like I should be able to redirect my logs to the file. It's talking about all the flags and all. There's certain GNU CLI standards that they have published. Like your command line app should support version and help, and input doesn't take any option, but for -o is for the output file. So these are few of the things you might want to keep in mind when you're writing CLI apps. And we also believe that CLI apps could be the first consumer of your services. So while developing a web app, we write a lot of REST APIs, and what we try to do is that we actually, that's generalizing. One of the common trend is you write a web app in front of it to consume those APIs and then drive your test through those through the web app. The other way of doing it can be just have your CLI be the consumer of the REST API. So what it gives is that it gives cheap functional tests. You can they are easy to build, they are fast, the execution time is less, and you don't have to involve yourself in like rich UI of the web app. Like you definitely have to have a web app, but the CLI app can be the first place where you which consumes your web services. So yeah, I'll let Nikhil talk about the ideas.
So yeah, we thought it would be cool to have a few ideas that you guys can go ahead and experiment, maybe write CLI applications. You can, as Shishir told us, you can have a CLI app that can successfully crawl a RESTful API, like maybe the one that GitHub provides. You can also have, if any of you guys use Knife, there is a serious lack of plugins out there that integrate with a solid like an SCM tool, like a version control software. So maybe that is potential. That's a potential out there. If you have really complicated Rake scripts, let's remember that Rake is actually just a build tool. So if you are doing anything more than that, just to use its task architecture, it's probably worthwhile for you to rebuild that like a proper first-class CLI application, and I don't know, distribute that, maybe make it more generalized. It's a fun thing. You guys can the online version of this presentation is at that URL, and I'm Nikhil. This is Shishir. We tweet at these places, and yeah, thank you. Do you have any questions, any suggestions, any more ideas?
Hello. Hi. Actually, I kind of had some suggestions. I come from a system administration background, so my point of view is totally, when I'm using a command line application, my point of view is from a system administration perspective rather than a Ruby developer perspective. And some of the important things that are generally not handled well, for instance, by something like Capistrano or Bundler, one is exit statuses, respecting the privileges of the user. For instance, when you type bundler, it goes and modifies your system as a whole. There's a hidden option somewhere that you will have to spend hours on the website trying to figure out, called double-path.
Yeah.
So these are some of the mistakes I think that are made by Ruby developers who are not, you don't necessarily have command line experience by default. Another thing I would suggest paying close attention to is pipelining of apps. Unix command line is built on the principle that you have small tools that do specific tasks, you hook them together, you get bigger tasks done.
Yeah.
One of the most basic ways of doing this is like, for instance, writing pipelines. So I would suggest that honestly, people who are looking to write command line applications actually learn the shell properly.
Of course.
So that's all I just wanted to add. And yeah, thanks.
Yeah, thanks. Nice suggestions, both of them. Probably one of the things about bundler is that it falls into this strange space where it is used as much as sysadmins as well as by developers. But yeah, like sure, you can like there is a .bundle file which accepts all sorts of configurations, so you can maybe send in a patch.
Right. Hi. So one thing I've noticed when writing CLI apps, especially in Ruby, is I find pretty inconsistent behavior when I'm dealing with buffered output from subprocesses. And so, for example, some cases I have to explicitly put flush. Some cases it just works. So, have you had any experience like that? And do you have any recommendations for making this work cross-platform?
Yeah, mostly we have been using Mixlib CLI, which is a wrapper around io.select, and it gives you the control on all standard in, standard out, standard air. And in that part, at least, when we were writing the command line app, we didn't face the problem of buffer. But what we had to do occasionally, or what we do, like as standard practice, is to sync all the 3 strings always, like whenever we are writing the command line. Yeah, but the answers are like we have not faced the flushing problem of the buffer.
Yeah.
Last question. Hi, thank you for the valuable input. We have started a open source project called ISP Unity. I'll be giving a talk in the afternoon at 3:30 regarding that. So it is a command line application for load balancing on multiple internet connections. We will be releasing it as a Ruby gem, and we will certainly appreciate if you guys can also contribute to the project with your expertise and to that.
Sure.
Definitely. Thanks. All right. Thank you, guys.
Thanks, guys.